Hello students, in this session we are going to see about active filters, nonlinear amplifier and relaxation oscillator. First we will see about active filters. Active filters are the circuit. It is a frequency selective circuit which passes a specified band of frequencies. It passes only a specified band of frequencies and it blocks or attenuates the signals of frequencies outside of this band. In active filters, there is a transistor, operational amplifier, transistors or operational amplifier, capacitor, resistors. All these components are used. The RC network are used for the filtering. RC network is nothing but a resistor capacitor network. There are few types of filters: low pass filter, high pass filter, band pass filter, band stop filter, and all pass filter. See low pass filter. The first one is low pass filter. Low pass filter allows the low frequency signals. So here the high frequency will be calculated. So till here all the frequencies will be allowed. Till here from 0 to FH all the frequencies will be allowed through pass through the circuit. So remaining frequencies are stopped. Next high pass filter. Here it is opposite to low pass filter. The low frequencies are stopped and high frequencies are allowed here. Next band pass filter. One particular band that will be calculated that is cut off from cutoff frequency. So one particular band is allowed through the circuit. Next band reject filter. This is opposite to band pass filter. In band pass filter, one particular pass is band is allowed, but in band reject filter one particular band is rejected. Next all pass filter, it allows all the frequencies but it provides a phase shift. So you can see here positive negative. For the negative it is positive, so it provides the phase shift. Next nonlinear amplifier. In this nonlinear amplifier circuit, the gain value is a nonlinear function of the amplitude of the input signal. See, the gain may be large for weak signal and it is very less for a smaller signal. This can be achieved by connecting the PN junction diode in this format. So this is the circuit for nonlinear amplifier. Positive is grounded. This is operational amplifier. Positive is grounded and negative is connected with input voltage, and these PN junctions, two PN junctions are connected in this way. Working for small value of input signal. So I said for small value of input signal gain is high. For high value of input signal gain is low. So we'll see how it is. For small value of input signal, these diodes are acting as open circuit and the gain is high because it provides very less feedback. So due to this minimum feedback, the gain of the circuit is high. Next case, when the amplitude of the input signal is large, these diodes offer very small resistance and hence the gain will be more. Next one is relaxation oscillator. A relaxation oscillator, it's a free running oscillator. Free running is nothing but there will not be any input. It is a free running oscillator. It produces a square wave. So here the square wave is based on the charging and discharging time of the capacitor. So see the circuit, this is operational amplifier. Positive terminal is connected with the resistors R1 and R2. These R1 and R2 are acting as potential divider. And then one capacitor is connected to the inverting terminal, and again one more positive feedback resistor is connected, that is called R. So this is charging time, charging and discharging of capacitor. So this is a upper threshold voltage, lower threshold voltage. See the output, it switches between plus Vsat and minus Vsat. Now see, there is no input but still we will get the output from this circuit. So this, we'll see how. So as I said, the output is switching between plus Vsat and minus Vsat. So first we will consider the output is plus Vsat. So see here, output is plus, we consider output is plus Vset, and due to this feedback resistor, the capacitor will start charging to plus Vset, but it will not reach the plus Vset. Before that, it will be switched to minus Vset, because there will be a negative upper threshold voltage. So you can see here, it will not reach the assume that the output is positive saturation, that only I told it is a plus Vset. We will assume that because of the feedback resistor or the capacitor will charge towards the plus Vset, but the capacitor voltage will never reaches the plus Vset, because the voltage crosses the UTP, upper threshold voltage. So when the capacitor voltage crosses the upper threshold voltage, the output voltage again switches back to minus Vset. Now the output voltage is minus Vset means it is in negative saturation. So the capacitor now it will start discharging towards the minus Vset, but again it will not reach the minus Vset. Before that, lower threshold voltage will be there. So when it reaches the lowest threshold part, again it will go back to the plus saturation voltage. So from that we will get, so the here out capacitor voltage switches between upper threshold voltage and the lower threshold voltage. Because of that, we are getting plus Vsat and minus Vsat. So this is how the relaxation oscillator is producing square wave. Here the time constant T is equal to 2 RC. The formula for calculating time T is equal to 2 RC ln 1 plus beta by 1 minus beta. Here beta is equal to R1 by R1 plus R2. This is potential divider. R1 by R1 plus R2. Thank you.